Dear students, I am from Excellence Educare. In the previous class, we have discussed about Newton's first law of motion. That is the laws of inertia also. Inertia and the different types of inertia. We have already discussed in the previous class. Okay. Now, we will discuss some questions and with answer that related to Newton's first law of motion or inertia, related to inertia. Now the first question is question number 1. Okay. Explain why some of the leaves of the plants may get detached from a tree if we vigorously shake its branch. Okay, now I am writing this question. Explain why some of the leaves may get detached from a tree if we vigorously shake its branch. Okay, the answer is like this. I am telling the answer first. Listen carefully. Listen. The leaves of the tree have inertia for rest. Initially, inertia for rest. When the branch is shaken, it moves. The branch moves, na? But the leaves tend to be in a state of rest due to their inertia. Thus, the leaves get detached from the tree clearly. So I am writing the answer. The leaves of the tree okay, have inertia for rest. Have inertia of rest initially. Okay. When the branch is shaken, it moves, but the leaves tend to be in a state of rest due to their inertia. Clear? Thus, the leaves get detached from the tree. Clear? Okay, from the tree. Clear? Now, question number 2. Question number 2 is the just long type answer. So I will just tell. I will not write it because it is long. So that I will just tell. The question is like this. When do you fall in the forward direction when moving bus brakes to a stop and fall backward when it starts from rest. Do you understand what is the question? When do you fall? When do you fall or when do we? When do we fall in forward direction? When a moving bus brakes to a stop and a fall backward when the bus starts from rest. Clear? So, first the answer is like this. So now I am writing the question. I am writing the question and I will explain the answer. Okay. So, when do we fall in forward direction? When a moving bus brakes to a stop and fall backward when the bus starts from rest. Okay. The answer is like this. So just I will just explain the answer. I will not write it because it is a long answer. So listen carefully and you may write down. I am telling the answer slowly. I am telling the answer, so you can write it also. Okay. The passenger possess the passenger in the bus, na? The passenger possess inertia of motion in a moving bus. In a moving bus. When the bus stops, the lower body of the passengers, which is in contact with the bus, also stops, while upper parts of the passenger tend to keep moving as they fall, so that they fall forward. Clearly. Similarly, in a stationary bus, when the bus is stopped, when the bus stops, so in the stationary bus, the passenger have inertia for rest initially. So when the bus starts, the lower body of the passenger move, but the upper body tends to be at rest. So the passengers fall backward. Clear? Okay. This is the answer. Now question number 3. I am writing the. Okay. Now question number 3. Question number 3. When a carpet is beaten with a stick, dust come out of it. Explain. I am writing just. When a carpet is beaten with a stick, dust come out of it. Why? Or explain it. Explain. Explain करो. Come out of it. Explain. Okay, I am writing the answer. I will tell and I will also write. Okay, the answer is the dust particles lying on the carpet possess what? Inertia for rest. Initially possess what? Inertia for rest. When the carpet is beaten, then dust particles resist the change in state of rest. So, fall down. Clear? So, I am writing the dust particles lying on the carpet, particles lying on the carpet possess inertia for rest. Initially, inertia for rest. When the carpet is beaten, dust particles resist the change in state of rest and so fall down. Clear? And so fall down. This is the third question. Okay. Now I am writing the question number 4. Question number 4. So question number 4. Why does a player run for some distance? Player run for some distance before taking a long jump. Okay, question is like this. The answer: the player runs for some distance before taking a long jump because in doing so he picks up inertia of motion which help in covering a longer distance. Okay, so I'm writing a player runs for some distance before what taking a long jump because in doing so he picks up inertia of motion which helps in covering a longer distance. Okay, clear? Next, Newton's second law of motion. Before knowing Newton's second law of motion, we have to know what is momentum, because momentum is related with Newton's second law of motion. So what is momentum? First write down. Momentum. Momentum. What is momentum? The quantitative motion of a body is known as its momentum. What is quantitative motion? What is quantitative motion? Quantitative motion means what is the amount of substance contained in that body. That is its mass. That is its mass. And what is its velocity in which the body moves. So, momentum is defined as the product of mass of the body and velocity of the body. Okay, mass and velocity. So we can write momentum, the quantitative motion of a body is known as its momentum. Okay, known as its momentum. Quantitative motion means what is the amount of substance contained in the body, that is its mass, and what is its velocity in which the body moves. Okay. So momentum is defined as the product of mass and velocity of the body. So momentum is defined as the product of mass and velocity of the body. Clear? This is called momentum. Okay. So mathematically you can write momentum is equal to velocity, mass into velocity. So we can write mathematically momentum can be abbreviated as what? P. Symbol of momentum is P equal to m into v, mv, mass into velocity. Okay, mv. Momentum is a vector quantity. Why? Because momentum is product of mass and velocity. Velocity is a vector quantity. So momentum is also a vector quantity. So you can write momentum is a vector quantity. Previous class I have already told you what is the vector quantity. The physical quantity which has both a magnitude and a direction is called a vector quantity. I have already told in previous class. Okay. So momentum is a vector quantity. Its direction is same as the direction of the velocity That means the direction of a momentum is same as that the direction of the velocity. Clear? Okay. Now the SI units of momentum, because momentum, SI units of momentum. The SI unit of momentum is what? Momentum equal to mass into velocity, m into v, na? So SI units of momentum is mass into velocity. Mass into velocity means what? Mass means kg into velocity meter per second. that means kg meter per second. SI units of momentum is kg meter per second. Kg for mass or meter per second velocity, because momentum is mass into velocity na. So kg for mass or meter per second for velocity. So SI units of momentum is kg meter per second. Clear? Kg meter per second. Okay, clear? Now Newton's second law of motion. Newton's second law of motion. Newton's second law of motion. Okay, Newton's second law of motion. It states that the external force acting on a body is directly proportional to the rate of change of its momentum. I told you momentum is related to Newton's second law of motion. So the rate of, clear. So mathematically we can write, okay, if a body of mass m is moving with velocity u and an external force F, that is denoted by F, changes its velocity to V, that is final velocity. Initially the body moves with the body of mass m moves with a velocity u, and an external force F changes its velocity to what? V in time t. Clear? Then force, according to Newton's second law of motion, force F, that is proportional to what? Force means F, proportional directly proportional to rate of change of momentum. Rate of change of momentum. Force is directly proportional to, according to Newton's second law of motion, force is directly proportional to rate of change of momentum. So that is F. Force means force. That's force means F. Proportional. Rate of change of momentum means what? Change in momentum by time. Rate means time rate. That is change in momentum by time. That is rate of change of momentum. Rate means time rate. Okay. So force directly proportional to change in momentum by time. Clear? Force F proportional to change in momentum by time means change in momentum means final momentum minus initial momentum. Time means t. Okay. So force proportional final momentum means what? M মানে mass into final velocity v minus m মানে mass into u initial velocity, that is. So final momentum means mv minus initial momentum মানে mu by time means t. Clear? So f proportional mv minus mu by t. Clear? Implies that f proportional m is taken as common, m bracket में v minus u by t. So m is taken as common. Force proportional m into bracket में v minus u by t. Clear? Implies a proportional m into a. Why a? Now v minus u by t means a acceleration, that is the rate of change in velocity. V minus u by t. V minus u by t means rate of change in velocity, that is acceleration. So m into a. M into v minus u by t means m into a. So f proportional m into a. That implies f is equal to k into ma, where k is a constant of proportionality. F is equal to k into ma, where k is the constant of proportionality. Constant of proportionality. K is the constant of, so F is equal to K into MA. And overall we can say F is equal to MA. F is equal to MA. Force is equal to mass into acceleration. So Newton's second law gives what? The measurement, that is the quantity of what? What is force? The mathematical value of force. Newton's second law of motion gives the mathematical value of force. Force is equal to mass into acceleration. Mathematical value means mathematical expression. Mathematical expression of a force. Newton's second law of motion gives mathematical expression of force. That is F is equal to mass into acceleration, MAA. Clear? Next, unit of force. Unit of force. SI unit, unit of force. We know that F is equal to MA. We found, we knew that from Newton's second law of motion, F is equal to MA, mass into acceleration. Clear? So the SI unit of force, SI unit of force is equal to what? F is equal to MA. So M means kg, kg for M. A means what? Meter per second square. Kg for mass M, or meter per second square for acceleration A. F is equal to MN. So M matlab kg into A means what? Meter per second square. So SI units of force is kg meter per second square. That is called Newton. Newton. Okay. So SI units of force is equal to kg meter per second square, or Newton. Okay. Or Newton. So SI units of force. If M mass equal to 1 kg our acceleration, that is A, is equal to 1 meter per second square. Then force means F. Force means F is equal to 1 kg into 1 meter per second square. Plus kg means mass na, m into a acceleration nahi. So F is equal to 1 kg into 1 meter per second square. That is kg meter per second square means Newton na. That is 1 what? 1 kg into 1 meter per second square means what? 1 kg meter per second square. 1 kg meter per second square. 1 kg meter, 1 kg into meter per second square. That is what? 1 Newton. 1 Newton. If mass m is 1 kg and acceleration a is 1 meter per second square, then force F is equal to 1 kg into 1 meter per second square, that is 1 kg into meter per second square, that is 1 Newton. 1 Newton. Okay. So we can define what is 1 Newton. What is 1 Newton? We can define it. It's a very important question. What is 1 Newton? Okay. So what is 1 Newton? We can write 1 Newton is defined as the amount, the amount of force that produces an acceleration of 1 meter per second square on an object of 1 kg mass. Clear? 1 Newton. What is 1 Newton? If the question will arise, what is 1 Newton? So we can write 1 Newton is defined as the amount of force that produces what? An acceleration of 1 meter per second square on an object of 1 kg mass. Clear? So this is the definition of a Newton. What is Newton? Okay. Now one question. I am writing a question that related to Newton's second law of motion related question. The question is like this. A player catching a moving ball moves his hand backward. Why? A cricket player. Why? Suppose a cricket player catching a moving ball moves his hand backwards. Before catching the ball, he moves his hand backward. Why? So write down the question. A player catching a moving ball moves his hand backwards. Why? So before writing, I'm just explaining the answer before writing. Okay. In doing so, the player increases the time during which the high speed of the moving ball decreases to 0. Clear? In doing so, the fielder increases the time If he moves it his hand backward, so time will increase na. So in doing so, the fielder increases the time during which the high speed of a moving ball decreases to 0. Thus, the acceleration of the ball decreases. The acceleration of the ball decreases, and therefore the impact of catching the ball is reduced. The impact of catching the ball is reduced. So write down the answer, right? Just in doing so means the player moves his hand backwards. Okay, so the player moves his hand backwards. Okay, so in doing so, the fielder means the player, the fielder or the player increases the time during which in which time during which the high speed of moving ball decreases to what? 0. Decreases to 0. Thus, the acceleration of the ball is decreased, and therefore the impact of catching the ball is reduced. The impact of catching the ball is reduced. So that's why the player moves his hand backwards before catching a moving ball. Clear? Okay. In the next class, we will discuss Newton's third law of motion, application of Newton's third law of motion, and a law of conservation of momentum. Okay, in the next class we will discuss this. If you got some advantages from my class, please like to my channel, also share it and subscribe to my channel, and also click the bell icon and set it all. Okay, thanks.